now introduce Aziz Boxwala, just harking back to some themes that have already been raised in the meeting. In my presentation earlier this morning, I talked about different kinds of computable biomedical knowledge, different kinds of biomedical knowledge, one of which is practice guidelines, and made the point that they don't come out of the box in computable form. And if we are going to move toward this second knowledge revolution, we have to make them computable. This was a major theme of the presentations from our colleagues at NICE. So to continue along this very important theme, we now welcome Aziz Boxwala, whose work in this area of making practice guidelines computable has been foundational and transformational. A bit more about Aziz. He's the president and co-founder of Alimu Informatics Incorporated. His expertise is in clinical decision support and healthcare data interoperability. He's a participant in the clinical decision support working group at HL7 and involved in many other related endeavors. At Alimu, he leads the research and development of interoperable clinical decision support and workflow applications. Prior to that work, he was a faculty member in medical informatics at the University of California, San Diego, and at the Harvard Medical School, and was director of medical informatics at Eclipsys Corporation. So his work has been on both the academic side and the industry side. He was one of the lead developers of the guideline interchange format and is the principal author of the multi-year knowledge transition framework that he will describe in today's presentation. So Aziz, thanks very much for joining us today, and let me turn things over to you.
Thank you so much, Chuck. I hope you can all hear me okay?
You're rather quiet, Aziz.
All right, let's try this. Any better?
Still rather soft, but at least we can hear you now.
Okay, let me pull the headset off and
Can't hear you at all now.
sorry, Zoom crashed on my computer while I was unplugging my headset. Are you able to hear me better?
Ah, yes, you're getting a little louder now. Yes.
Okay, all right, excellent. I'll try and speak a little bit louder. I just
Great, thank
recovering
you.
from a sore throat, and
Oh dear.
so apologize for that. Chuck, I guess you forgot to mention one of my credentials, which is that I was your mentee at when I was doing my PhD, so many years ago. Thank you for that. Yeah. So as let me share my screen. So I think I'm sharing the right screen, which is the full PowerPoint presentation. And as Chuck mentioned, I'm going to talk about translating clinical practice guidelines for decision support purposes. And let's go to the next slide. Right. So just a quick summary of what you're going to hear, which is, I guess by virtue of you all being on this call, you know that medical knowledge is growing very rapidly, and it does challenge the ability of clinicians to keep up with it and use that knowledge in caring for patients. Right? So clinical decision support tools provide a potential solution for us to be able to deliver that knowledge to the clinicians at the bedside when they're managing that patient, right? The relevant knowledge that they need. Nevertheless, adoption of CDS remains limited even today, right? There are many issues that keep it from scaling up. One of those is the effort to create computable knowledge, right, to be used within CDS systems. And to that end, we created the multi-layered knowledge translation framework a few years ago to be able to scale the translation of clinical practice guidelines into knowledge artifacts that can be used for CDS. Still, some amount of work, a lot of work actually remains to be done to be able to scale that knowledge translation effort. So here's kind of one excerpt from a published article from a few years ago, and it says knowledge is growing really rapidly, right? So it's in 1950, the time for doubling of medical knowledge was about 50 years. Today, they're saying it's about 0.2 years, right? You may or may not agree with this statistic or with the impact of that clinically, but we all, I guess, agree that it's growing knowledge is growing really fast, and it is going to create challenges in making sure that the most current evidence is used in care. So just as an example, this is a graphic from a study done on ClinVar. ClinVar is a knowledge base or database that is maintained by the NCBI in the US, the National Center for Biotechnology Information. And what ClinVar does is store clinical variants in genomic data, or sort of clinically significant variants in genomic data. And you can see out here that this graph here shows the growth of the variants in that database over a 2-year period from March 2002 to March 2024. And these are just 24 genes that are used that impact the likelihood of cancer, right? And you can see that this database grew about 50% in 2 years. That's tens of thousands of new variants in those 24 genes. And even the pathogenic and likely pathogenic genes grew about the same percentage. So that's really fast, and it does make it hard to keep up with the evidence in just 2 years if it grows 50%. Right? And that's where CDS comes in. So clinical decision support. It's a way for us to provide that knowledge, right? Deliver it right to the bedside, to the clinicians in part of the EHR or other tools they might be using in the care of patient, and in the form of actionable recommendations. So just not knowledge, but we can make that, a actionable thing, like an orderable recommendation, something they can just order with the click of a button. This is a definition of CDS that I used, and it's attributed to Dr. Ashraf, who I think is on the call right now. And it's this provision of pertinent knowledge. So that's the knowledge that the clinician needs to take care of the person right in front of them, right? And it's about that patient, helping them make that decision about how to manage that patient's care. And when we look at this broad sort of definition, we think of CDS as not just being alerts and reminders that are typically thought of when you think about CDS, but other tools available within EHR systems and other health information technology systems. So things like documentation templates, order sets, context relevant data summaries, and I'll show you some examples of these. And even things like info buttons, which is where you click a button and in the EHR, and it brings you information relevant to that action that you are going to do in the EHR and relevant to that patient that you are looking at. Right, so here's some examples. So this one is from an EHR system in a hospital I used to work at, Brigham and Women's Hospital in Boston. And as you can see, it's from 35 years ago, almost. And it's just alerting the clinician about an allergy the patient has to the antibiotic they're about to order. And this is something that Dr. Bates, who was a physician at the hospital and a professor of also there, he published a lot about and has demonstrated that there's been a big impact in reducing the frequency of errors. Another example some colleagues of mine had developed. This is for the management of hypertension, and it's also from the 90s, so relatively old. Again, shows suggesting secondary causes of hypertension in this case, and also providing some actionable recommendations here. This is a more recent example of CDS that my colleagues and I developed. It's for a CDC guide based on a CDC guideline, and it's the CDC guideline changed from recommending ceftriaxone 250 milligrams to ceftriaxone 500 milligrams for the treatment of gonorrhea. And so this CDS alert was intended to bring, clinicians who are still using the old guidelines, bringing them up to, bringing in the more current evidence. And this here is an example of a more of a context relevant data summary. I'm not sure if you can read it all clearly, but it's showing data relevant to hypertension. And it shows blood pressure data, both patient reported and clinically obtained, medications the patient's on, adherence to that medications, patient reported adherence to the medication, recent lab results, encounters, all of that on a timeline. And it's kind of helps the clinician maybe understand why the blood pressure might be not well controlled, right? And in this case, they can look at the blood pressure, they can look at the medications and understand that. And what you see out here is that the patient's indicating that they haven't been using the medications because they have dizziness from this medication. And it helps the clinician understand that maybe it's not the medications are not working because the patient's not taking them, right? So don't add a second line, maybe substitute the medication. Here's another one which is more interesting. So this one was built to support post-operative recovery of patients, and it's built around a management plan that the organization had for treating patients according to enhanced recovery after surgery guidelines. And in this case, we are showing the clinicians the pain management that's going on post-operatively. So here's the kind of procedure that occurred for this patient, the pain scores so this is all during the hospital stay. Right? And yeah, so pain scores that they recorded in the patient's EHR and the opioids that were administered. And the challenge the clinicians had, the surgeons had managing opioid was that different opioids have different potencies. And it's kind of hard to understand what the amount of opioids you've given because of that. So we computed something called the morphine milligram equivalence, or MME, that normalized that opioid administration, and just displayed this to clinicians, right? And along with the active orders for opioid and non-opioid analgesics, so they had a good view of what was going on in terms of opioid usage post-operatively. And this simple tool was effective enough to actually make a big difference in the use of opioids. So there was a huge reduction in the tramadol prescribed to the patient at discharged, right? And even the MMEs. So they were tramadol was substituted with other opioids, but the total MMEs also was reduced by 62%. Another example of a CDS tool is a risk calculator. So this is what's called a Smart and Fire app. Many of these apps have CDS tools I've shown you are Smart and Fire apps. And what this one does is it's computing the risk for diabetes in patients who have pre-diabetes. And it's filling in this form, the risk variables, with data from the EHR, as you can see out here. And it lets the clinician maybe fill in any missing data or change any data that the EHR may not have been up to date about. Right? And when they calculate the risk, they get the risk level there's a 10-year risk for diabetes. And it also shows what they can do to reduce that risk. So if in this case, there's a bigger impact from changing the patient's lifestyle, right? Which reduces the risk by more than 58% or 58%, versus just using metformin, which reduces the risk in a much lesser amount. So all of these tools, I mean, we have had our, clinical studies, evaluation studies that showed CDS's effectiveness for almost 50 years, and published papers by Dr. McDonald, Ken Kawamoto, that show that there's a significant improvement in using in clinical care as a result of using CDS. So here's Dr. McDonald's paper back from 76, or 49 years ago. But we want to use more CDS, and we'd like to, but can CDS keep up with this knowledge growth, right? So if there's a guideline, so this is that same guideline that I showed you the CDS for earlier. So when there's a guideline published, we have someone, a knowledge engineer, who takes the guideline, translates it, and puts it into an EHR, right? And they're often assisted by clinicians and committees who review that work before it gets used. So it takes a significant amount of work to take this and make this happen. Now, this exercise kind of gets repeated at every organization that wants to use that CDS, right? So we can do better than that. And one way we can do that is by sharing the CDS that's developed, right? So if I can create a library of these CDS knowledge artifacts, I can send them to a EHR system, or like my EHR system can download them and use that, right? And they have the data for the patient, and I can run the CDS and can reduce the effort to create this to use CDS within my EHR system. There's another model that's evolving now because of changes in technology and different data standards. So we have an EHR system, but I can actually use an external decision support service, something sitting in the cloud, right? So I can send it a request saying, here's my patient, here's some data about the patient. Now tell me how I should care for this patient, and I get back some guidance. It's a different model in this case, so the artifacts within the CDS service, and we're sending it data. In the first one, we sent it the knowledge, and the data has kind of remained within the EHR. So two different models. The rest of the talk is going to be mostly about the knowledge artifact sharing, not CDS services. Right. So if you look again at that same diagram, what we would like to do is have this knowledge engineer translate the guideline, put in a repository in a shared library somewhere, and we want everyone to use that, right? So it just reduces the effort, maybe gets things out faster. But that itself presents some challenges. So EHR products, they should be able to consume that knowledge artifact. They vary in their features, their data structures, whether they'll be able to understand the language in which I share. Each EHR seems to have a different language used for their CDS logic. We can solve that problem by using some standards for sharing knowledge artifacts. And we'll talk a little bit about that. But healthcare organizations themselves have different workflows, different policies. So how do I make that same decision support logic work in two different EHRs? And they also have different resources and services available. A small rural hospital, maybe 400 miles away, or 6 hours drive away from the nearest MRI capable machine. So they may have to manage care differently. Right? So that's all of that kind of ability to create knowledge artifacts that are shareable, even in very different systems, led us to create this multi-layered framework for translating guidelines into computer-based decision support logic. And I should point out this work was funded by the Agency for Healthcare Research and Quality, AHRQ. As part of the CDS consortium, whose principal investigator was Dr. Blackford Middleton. So here's what that model looked like. Right? So there are 4 layers we described in that model. The first one was simply the published guideline. Right? So it's large narrative text, typically or often up to 200-page PDF documents that you really don't expect a clinician to use at the bedside. Right? It's broadly shareable. Everyone can use it. It's independent of any particular clinical site. And it was created by the guideline developer, often a professional medical society or even a government agency. The second layer of the model was someone going through that, distilling out from it, here's what we think the CDS should look like, and putting that in a text document. You can think of it as a specification for the CDS, how the CDS should function, right? Again, it's shareable, it's site independent, it's just text organized a little bit differently, and it's authored by someone who understands how it's used clinically, usually a clinical domain expert, right? Subject matter expert. The third level is now that same text knowledge is codified. It's the logic in that is put in some kind of a formal language. We put in codes for various clinical data, like what do you mean by diabetes? It's these 20 codes from ICD-10 or 200 codes from ICD-10 and another 300 codes from SNOMED, right? So all of this has been authored by the knowledge engineer by reviewing this level 2 semi-structured guideline. And then level 4 is someone taking that logic and putting it into a healthcare organization's EHR, adapting it to that organization's workflows and policies, right? And so that's not shareable. That's kind of used directly within that site. And what you see out here is that as you go up from the narrative guideline to executable knowledge, you get more and more precise and more executable, right? But you start to lose some flexibility and adaptability. Right, so just another view of that, right? So the first layer is a published guideline. The second layer is some organized text. Then we get into structured recommendations where we're putting the knowledge in a more formal syntax. And finally, EHR specific tools. And here's another look at that same thing. So here's an example from an old US Preventive Services Task Force guideline, which recommends screening for high blood pressure in adults. And here's what a semi-structured recommendation could look like. So someone saying, yes, in any patient who's age 18 or older and the blood pressure was not obtained in the last year, here's what I want as the recommended action. So back when we built the model, this was more than a decade ago now, we were using a standard called Jello. So this just shows an example from Jello and used a very different data model, a HL7 version 3 model. Now we've migrated to using CQL and FHIR, and I'll show you some more recent examples from that in a few slides further down. And then someone can take this and put this into Ardent syntax, which is a rule language that is, or was at least, supported by several EHRs. Right. So this, I think we can skip over this. This summarizes what I just talked about. So in the last few years, this framework's been adopted by few organizations. So this is a screenshot from HRQ's CDS Connect repository, and this repository was developed to be able to share knowledge artifacts. And so the sharing was kind of using this multi-layered model, as you can see out here. And various organizations contributed knowledge to this repository. HL7's new standards for clinical practice guidelines also adopt this framework for sharing knowledge. A lot of what's available or utilized is the level 3 structured representation, just because HL7 is a standards organization. And again, it's using FHIR and a new language called CQL, or clinical quality language. That's used as the L3 framework. And this is an example, except from WHO's SMART guidelines, where they've actually extended the model to add a 5th layer to it. And we've also helped several private sector organizations who are building clinical decision support technologies and content to utilize this model. So this is a more recent example that my colleagues and I developed for the CDC guideline that I'd shown earlier. And you can see this is kind of was our L2 model, the semi-structured recommendation, and we use spreadsheets to manage that. So we just put all the decision support logic within spreadsheets to share with clinical subject matter experts, showing them, okay, here's the logic. When a patient with whose weight is less than 150 kilograms with no allergy presents, and what recommendation do we give them versus patients who have a higher weight and have no allergy, and then patients with allergies. So there's different combinations. This then got translated into the level 3 logic. And this is an example of that same logic, but it's in CQL now. So this is an HL7 standard language. And finally, you've seen this one already. The level 4 got developed from this as and was embedded in 2 different EHRs using a standard called the CDS hook service. So in all these years, the impact on CDS adoption, I think this has actually had a, helped increase the publication of shared knowledge artifacts, right? And in big part was facilitated because HL7's FHIR and CQL provided another syntax for exchanging. So AHRQs, I mentioned AHRQ CDS Connect repository was sharing it in this particular format. And then AHRQ actually provided a online library for sharing. So both of those actually help. There were hundreds of CDS artifacts. The asterisk is here because as of October 1st, I think this repository is no longer available. This is part of the US government's reductions in funding. However, even though these knowledge artifacts were available, there's been limited uptake of these artifacts. It's largely because the EHRs and other applications don't really have the capability to utilize the knowledge artifacts in these formats as yet. We're starting to see some of those develop. And then the other thing is the other format, the other paradigm for sharing knowledge using clinical decision support cloud-based services provides another mechanism. So the need to share knowledge artifacts is in fact, maybe changing because of that. Right, so opportunities to improve guideline translation. So I think first of all, with use of standards, we compare this to electronic clinical quality measures. So so electronic clinical quality measures are required for healthcare organizations are required to report certain quality measures, and those measures are published in the same using the same standard in FHIR and CQL, and there's greater adoption of those in part because they're required by regulation. So in the US, right? So if you're providing clinical services for patients with Medicare or Medicaid, you're required to report certain things, and those measures are published as FHIR and CQL, and so there's much larger adoption of those. For CDS, the same standards, much less adoption. So if there's some regulatory changes to require more CDS, that can impact the adoption of guideline-based CDS. Then there are newer standards that are actually helping. So US Core in the US is a refinement of the FHIR standard, and it sort of makes it much more robust, much less variable in terms of how data are exchanged. And that's actually improved how we can share how we can use shareable CDS knowledge because it's consistent in how data is available from different electronic health record systems. The amount of consistency in those data across different EHR systems from different organizations is improved significantly as a result. There's also opportunities for guidelines to be used in patient-centered CDS. And what I mean by that is CDS that we present to patients, or CDS that's using data that's provided by patients. So now with remote patient management and others, patients are sharing much more data that they're creating from devices and apps. And there's like some of the current guidelines, it's hard to apply it to those data. So there's kind of need for new guidelines, new opportunities for clinical decision support to be implemented to support those. All right, that was it. Thank you very much. If you like to talk to me after the conference too, here's ways to reach me.
Thank you very much, Aziz. I have a couple of questions for you, and I know that Philip does as well. And we'll see if anyone puts some questions into the chat. One question for you goes to this idea of a knowledge engineer. You've referred at many points to things that knowledge engineers can do. That's a term that's been around for a long time. Can you put a modern spin on that idea? What what does a knowledge engineer do in today's world?
So I think knowledge engineer may be sort of seen as different roles in different places. I think they're informaticians who understand healthcare data really well. They understand healthcare workflows, understand how to program decision support logic into some formalism that can then be used to render CDS. So in some cases, they'll be doing it at level 3, which is putting in Fire CQL. In other cases, they might be using the tools provided by the EHR. So often they're even thought of as analysts in kind of the more sort of job roles that are available, working with EHRs. But they could be informaticians who've learned things like SNOMED, CT, and Fire and CQL.
Okay, thank you. That brings me up to date a little bit on what this term means. Before I turn things over to Philip, let me point to your use of the term library, which has come up several times previously in this meeting, and my remarks about the need for a library that serves to manage knowledge artifacts. The presentation earlier or after mine, but earlier than now, by Nancy Ali regarding the role of librarians if we're going to have libraries. And I really appreciate your carrying that idea of librarians and libraries forward. So that's great. We appreciate it. Philip's going to make some comments about something else that happened earlier in the meeting, and that is a presentation from NICE in the UK about what they are doing to make their knowledge artifacts computable, and I think these comments from Philip will also be very helpful.
Thank you. First of all, I should say, Aziz, we're very indebted to your multi-layer model for helping us think about what we mean by biomedical knowledge. So I certainly found it a formative piece of guidance in terms of how we address this problem space. So certainly in the earlier work we did with NICE in 22, 23, we used your framework in trying to think about where NICE is now, and obviously it's right at level 1 narrative guidance and what the target is to get to, and obviously implementers, actual EHR vendors are looking to implement stuff on CDS vendors right in level 4. But we're also thinking how our perspective on that, there's kind of the orthogonal dimension which you alluded to of how this is implemented. So if you're implementing it through an external CDS service like CDS hooks, then it's a different kind of perspective, isn't it? You're not only thinking about what level the content is, you're thinking about, well, is it search based? Is it prompted? What's the relationship between data in the EHR versus additional data that may be needed from other sources to complete the CDS logic? And specifically, I just wanted to pick up on the point of industry uptake, because as you rightly pointed out, one of the issues is every EHR, every CDS system does it differently internally. So even if you have quite a well-specified model, there's no guarantee that that will be implementable in a particular commercial product. And so the approach we're taking with our next stage of work with NICE, which starts next week, ironically, we're gathering together as far as we can all of the major EHR vendors in the UK, both primary care and secondary care, and many of the middleware vendors and vocabulary supporters and so forth, to really address the question, what do we have to do to make you implement it or enable you to implement it, rather than the other way around and saying, here's our standard, you need to change what you do. So what we're hoping is that we will arrive at a fairly straightforward consensus on the components that Sean was presenting earlier around. It's fairly obvious that we would use part of SNOMED CT to describe this aspect of the component, or we would use, in the UK, we would use a thing called DM&D, which is our Dictionary of Medicines and Devices for certain elements and so on. So I just wonder if do you see any mileage in a similar approach, either in the US or the broader HL7 community or other standards bodies, in terms of turning the question round to the vendors, to the product developers, to what do we need to do to make it possible for you to implement this stuff?
Yes, I do. And I think, in fact, I think the HL7 CDS work group is kind of expected to do that.
Mm.
There is a fair amount of vendor representation within the CDS work group. So I think there is that participation. I honestly think the other part of the challenge is, at least in the US, has been vendors have implemented what the regulations are required,
Mm.
right? And what their customers have asked for. But I think regulations asking them for a lot of things, and so they tend to prioritize, right? If it's yeah, they're essentially rebuilding their aircraft as it flies, right? They have their EHR, they
Yeah.
have to build all of these new features in while they're changing. So it takes a while for them to shift direction and build in the new features. But I think if there is a scenario for improving the ability to share artifacts, they will. We've seen at least one vendor now starting to implement Fire and CQL in the US natively within the EHR platform. I think there are more sort of at least open source tools emerging that support Fire and CQL as a service.
Mm-hmm.
So there'd still be a kind of hybrid of these two models of knowledge artifact sharing and not. So, but I think absolutely, I think we can do it without vendor participation.
Yeah.
Yeah. And I think the
Thank
bigger
you.
challenge, I think the part that's been, I'd say easier, not easy, easier has been the ability to kind of pull patient data to use CDS logic within that. It's the afferent side, the part where we suggest actions. That's been hard because I think that's even more different across EHR platforms. Like you want to suggest changing the antibiotic. I think that part's still not as standardized even within services.
Yeah.
So that's been harder, but getting at least understanding the patient data has been a little bit better.
Yeah, I think I would agree. I mean, the data exchange standards are far more mature. We don't have anything like that for the UI design, or the workflow design. So there are more fundamental differences there, aren't there?
We have some questions
Yes.
in the chat. From Damien, how do you latency or timing issues with clinical users in your implementation, especially when CDS hooks need to deliver decision support seamlessly within the medication workflow you showed?
Well, I mean, we've actually had this experience and with CDS services. So I think the question is about when CDS services are sitting in the cloud and the clinician user is going to receive that CDS from something in the cloud, but there's going to be latency issues because it's going across the network partly, but partly also it has to extract all of that data from the EHR and ship it across. And then we've experienced that issues, and we've had to iterate through just do a lot of optimization once we implemented it. So we had a with that gonorrhea CDS, for example, we started off with several seconds, and we were told to bring it down to 1 second of latency. And it required both. It required us to improve the performance on the cloud services side, but we also had to do some optimization of logic to actually be able to do that, to expect different data so that was going to be, not require so much data to be sent across the wire and extracted from the EHR. So we had to just iterate through it. I think we eventually got it down to like closer to maybe 2 seconds, not 1 second. But that's, yeah, it just required a lot of sort of, engineering work of trying to hammer away and find the problem and solve it and find the problem and solve it. No easy answer.
Gunesh Koru said, given some of the platform differences, what are the best strategies to reproduce the behavior of a CBK by its potential adopters?
Ooh, that's I guess what we just talked about earlier. I think it's it's standardization. I mean, as much as you can standardize, as much as we can get agreement, and I think some of that's going to be like by jurisdiction, right? In the UK, it might be a little bit different than in the US. But yeah, trying to standardize how much you can with shareable knowledge artifacts. It's going to be that. It's understanding what's common across different EHRs, across different organizations, making sure you put that common logic within the knowledge artifacts also. So you put in what the knowledge artifact is, and then you maybe even produce some implementation guides that suggest to the implementers, here's what you should do to implement this. Here are places where you might want to think about how you customize this behavior to your local organization.